Hello everyone, and in this video we're continuing with our work on tree diagrams, and we're talking about now dependent events. So dependent events, as the name suggests, is where one thing depends on the other. They're not independent of each other. So let's look at an example of this kind of question to get a feel for it. So in the first question it says Samantha has 9 white socks and 6 black socks of the same kind in a drawer. Okay. In the dark, she takes 2 socks at random, one after the other, out of the drawer. Draw a tree diagram and mark all of the appropriate probabilities. Okay, so let's have a look at Samantha's drawer. So here we go. This is a tree diagram representing the socks in the drawer. Okay, so what have we got? So we have got white socks and we have got black socks. Okay, so we're going to have white and we've got black. We've got white and we've got black. We've got white and we've got black. And then we've got sock number 1. There's my amazing diagram of a sock. So I'll call that sock number 1. And then here is sock number 2. Okay, so Samantha reaches in and she takes out 2 socks. Now, when Samantha first reaches into the drawer, there are 9 white socks in the drawer. Okay, so the probability is 9, and the total number of socks that are in the drawer is 15. So it's 9/15ths for the white. And the probability of a black sock is there are 6 black socks in there, and in total there are 15 socks in the drawer. Okay, so therefore we have got 6/15. So the thing that really helped me to think about this topic is this one is when you imagine Samantha first reaches into the drawer. So when Samantha first reaches into the drawer, there's 9 white and there are 6 black in there. Okay. Now, these branches here that with this pencil over it now, this is when Samantha she's taken one out already and she's now going to reach into the drawer for the second time. Okay. So let's imagine if Samantha selected a white sock first. Okay, so if Samantha had selected a white sock first, then there wouldn't be 9 in there when she goes to reach in the second time. There would only be 8 white socks in there. And there wouldn't be 15 socks in there. There would only be 14 socks in there. Okay, so if Samantha took a white sock out first, when she reaches in the second time, the probability of getting a white sock is now 8 out of 14 because the number of white socks has gone down by 1 and the number of socks altogether has gone down by 1. Okay. Now, when Samantha reaches into the drawer for the second time, the probability that she selects a black sock is still going to be 6 because there's still 6 black socks in there, but now it's out of 14 because there are only 14 socks in the drawer. So that is still 6/14 because Samantha did not take out a black sock. Okay, now let's look at this alternative version here. Let's imagine that Samantha first withdrew a black sock from the drawer. When Samantha goes to reach in the second time, there are still 9 white socks in there out of the 14 that remain. But because she's already taken a black one out, when she reaches in the second time, there are now only 5 black socks out of the 14 that remain in the drawer. Now, this is quite a big jump up in terms of level of difficulty compared to what we were looking at with the independent events. And at this point, this is the point where a lot of students find this a lot trickier. But as I say, thinking about this is going to reach into the drawer for the second time. What happens if a white one was selected first? How many white ones have I got left? How many socks are there left? How many black ones would be left in there if a white one was picked? And how many socks are there left altogether? Again, if I went to pick if I got a black one first, how many white socks are left in? Still 9. How many socks are there? 14. But if I picked a black one and I go to reach in the second time, how many black socks are in there? Just 5 now. and how many socks? 14. So that's the best way I can think of describing it. Okay, so that is our tree diagram complete for the situation. Now we've got to calculate the probability that Samantha selects a pair of white socks. So that is probability of white and white. And you remember that we said when we're talking about this and we hear the word and, we multiply along the branches. Okay, so we're going to do 9 15s times by 8 14s. And what I like to do at this stage is I like to avoid simplifying the fractions until the end. So that is 72, and then I'm going to have 15 times by 14 is 210. Okay, so I have got 72 over 210. Okay, so that's my probability of selecting white and white. So I'm going to write that down there, and that actually does simplify to 12 over 35. So that's our answer for the first one. Next one, this is part B now, a pair of black socks. So this is the probability of black and black. So the probability of black and black is going to be 6 over 15 times by 5 over 14. So black and black, so 5 times 6, that's going to be 30. And then it's still going to be over the 210. So now we've got 30 divided by 210, which is a seventh. So 1/7 is our probability of selecting black and black. So far, so good. 2 socks of a different color. Well, let's think about that. If there's 2 socks of a different color, we could have the probability of a white sock followed by a black sock, or we could have the probability of a black sock followed by a white sock. Okay, believe it or not, in the 1980s they used to have fluorescent socks, and it used to be quite trendy in the mid-80s to wear 2 different colored fluorescent socks. So you might have like a bright orange one and a lime one or something like that. It was like a fashion trend of the mid-80s. So that could be relevant for this. So let's think about this. A pair, 2 pairs, 2 socks of different colors. So in order to do that, we could work out the probability of white and black, or the probability of black and then white. Okay, so that's what we're going to need to do here, work out these 2 different branches. So the 2 different branches are going to be, first of all, let's work out the white and black. So white and black is going to be the probability of white, which is 9 over 15, times by the probability of black, which is 6 over 14. We know that that is 210, and then we do, that is going to be 54. 54 over 210 is the probability of white and then black. Probability of black and then white is going to be 6 over 15 times by 9 over 14. So 6 over 15 times 9 over 14 is going to be 210. And again, we're going to have 54. So now the probability of white and black or black and white is going to be 54 over 210 plus 54 over 210. Okay, which is going to be 108 over 210. And let's just simplify that down. 108 divided by 210 is 18 over 35 when it's simplified, which is our correct answer. So that's our probability of 2 socks of a different color. Next one, at least one of the socks is black. Okay, at least one of them is black. So now there's a longer way to do this and a quicker way to do this. The longer way to do it is to work out at least one is black. So we could say we can have this branch, white and black. We can have this branch, black and white. And we can have this branch, black and black. So we could work out those 3 branches and add them together, and that would give us our answer. Okay, but the alternative and quicker way to do this is, if we're saying that we only want to have at least one sock is black, the only option we cannot have is white, white. So we could do 1 take away the probability of white, white, and that would be quicker. So let's have a look at that. So that's going to be 1 take away 9 over 15 times by 8 over 14. So let's see what that's going to be. So if we do 9, so let's have a look at that. So 9 times by 8, that's going to be 72 over 210. Put our equal signs here. And we're going to do 1 take away that, which is going to give us, let's do that, 1 minus our 72 over 210 is going to be 23/35 for that one. 23 over 35. Okay, and that's our correct answer for part 4. So the quickest way to work that out was to do 1 take away white, white. Finally, no black socks. Okay, the probability that there are no black socks at all. Well, the probability that there are no black socks. So that is just going to be the probability of white, white. So that one, which we already worked out actually, probability of white, white, and white, white is going to be 9 over 15 times by 8 over 14. So let's work that out. So that is going to be our 72 over 210. And let's simplify that. 72 divided by 210 is 12 over 35. So 12 over 35 is our correct answer for that there are no black socks. Okay. Now, again, just to emphasize the point that I drew your attention to earlier, let's imagine that they said, they could say, what's the probability that Samantha selects exactly one of each color? Okay, so if they worded it in that way, the probability of exactly one of each color, that would be the probability of white, black, plus the probability of black, white. Okay, as I discussed earlier on. So that's what you would do if they said that use the word exactly one of each. Perfect. Okay, that is how we do dependent events on tree diagrams. And there's another fun question there for you to have a little look at yourself about budgies flying out of a cage. Okay, so you might want to have a go at that one. I'll see you in the next video.